Welcome to another practice revising for the EmSAT exam. In this video, we will be discussing the hydraulic system or the fluid pressure. In this question, we have a water piston that has two sides. Side A that has a square cross-section of length 0.25 meters and side B of circular cross-section of radius only 0.5 meters. The question is, what is the mass m, small m, that I need to add? So here I need to add a small mass, let's say a yellow small mass here, of mass small m, that it needs to be added to the square cross-section to lift the mass capital M, that is equal to 1000 kilograms on the circular cross-section, knowing that the height is 1 meter. Now these 2 points are on the same line, so basically the pressure on the 2 points A and B is equal. Now let us extend the pressure on each side. Starting with B, the pressure on B is actually nothing else than the force divided by the cross-sectional area. Now the force here is provided by the force of gravity, which is the mass, capital M, by G, and the cross-sectional area here, because it's a circular cross-sectional area, it is pi r squared. So on this side, I have no issues. I have the capital mass, G, 9.8, pi for sure, and the radius 0.5. On the other side, the pressure on point A is also the force divided by the cross-sectional area. Now starting by the cross-sectional area here, it is a bit different because it is a square sectional area, so it is length squared. Now talking about the force, not only the small mass is contributing by its weight, but also the height of water is also contributing by its weight. So here we have actually 2 masses, the mass of the water and the small yellow mass, weight time, so mass times G divided by L squared. Now the small mass, I don't know, G is 9.8, L is also given 0.25. Let me figure out the mass of the water. We need to recall the density of water, which is ρ, equals to the mass divided by the volume. Here again, I'm talking about the water. So the mass of the water by cross multiplication, the mass of the water equals to ρ of the water by the volume of the water. Ρ is actually 1000, and the volume of this, let's call it a triangle, is equal to length squared by the height. So the volume here is L squared by the height, giving that it is 1000 times 0.25 squared by the height, that is 1. Now replacing everything by its value, here so here I have a 62.5, and down, let me write it again here. On both sides, we can cancel, we can simplify by G. So rewriting the formula again, here I have 62.5 plus the mass, the unknown mass, divided by the L squared, which is 0.25 squared. And on the other side, I had the capital mass, which is 1000. We simplified by G, 9.8, divided by pi, and the radius is 0.5 squared. After computing, I will have that the mass is eventually equal to 17 kilograms. So the answer here is A. My mass, the small mass that I need to add, is 17 kilograms. Thanks for watching and best of luck.